day one notes. Take a look at example 1. They give you f of x equals 3x minus 5, and it says evaluate f of 0. So you guys know that's just function notation. Function notation tells you, basically what to do. Has a 0 here, that means you're going to plug in 0 where the x's are. So if we do that, we'd get 3 times 0 minus 5. If you do the math, 3 times 0 is 0, so you get 0 minus 5, or a negative 5. The whole point of this, though, is to kind of understand what answer you just got, what that answer means. All right, so with function notation, it really tells us a point. We plugged in a 0, we got out a negative 5, so it's telling us that 0, negative 5 is a point on the graph of f of x. So let's go back up to f of x right here. If you think about this graph, 3x minus 5, this graph is a line. Should know that because it's in the form y equals mx plus b. So that means 0, negative 5 is a point on the line. And it's actually a special point, right? It's your y-intercept. If you look at this, your y-intercept is negative 5. 0, anything is always going to be your y-intercept. So maybe write yourself a note there. Not really just any point. It's the y-intercept. Happens to be that y-intercept. All right, take a look at part B. It says solve f of x equals 0. So this time a little bit trickier. All right, they really don't give you the x value. You got to figure out the x that you could plug in to get a y value of 0. So I would just kind of think substitution here. Think of this side as an equation. All right, we've got f of x. We know what f of x equals. It's 3x minus 5. What if we just substitute in 3x minus 5 in its spot? Now we could solve for x. If we add 5 to both sides, you get 3x equals 5. Divide both sides by 3. You get x equals 5/3. Again, we want to know what that means, all right? That means if you plug in an x value of 5/3, you get out a 0. Or in other words, 5/3, 0 is a point on the line. All right, and let's think about, it's a special point. All right, think about 5/3, 0. All right, that's actually an x-intercept. All right, anytime you have the x value and the y is 0, think you'd go right 5/3. You wouldn't go up or down at all. That's going to be an x-intercept. So it's good to kind of just put it all together, that it's not just any point, it's a special point. It's your x-intercept. All right. Moving on to example 2, it says evaluate the function notation using the graph of g of x below. All right, so this graph is kind of in general, but we need to use it to help us. So in part A, function notation, g of 4 is the x value. They want the y value that goes with it. So go over to 4, follow it down. All right, the y value that goes with it is called h. All right, it's a letter, so that's the best we can do. That's our answer. All right, our answer is h. All right, let's look at part B. We don't know the x value, but we know the y value is I. We need the x. So look at your y-axis. This is a y value of I up here. All right, if we kind of follow that over and follow it down, the x value that goes with it is a. So a is your answer. All right, and then the last one, g of f. F is the x value. We want the y value that goes with it. So go over f, follow it down. Let's say it's this point right here and over here. All right, the y value that goes with it is g. So that would be your final answer. So you can answer these questions, even though they involved a lot of letters instead of numbers, you can still do it. We're really just talking about function notation, which is points on the graph. Let's take a look at example 3. It says if f of x equals x squared plus 3, evaluate the function notation below. All right, so again, function notation is a set of directions. It means a minus 2 is being plugged in for the x's, and I would always plug it in parentheses. So in that x's spot, we're going to put an a minus 2. We still need a square, and we still need a plus 3. And then it's our job to simplify this. So if we have to square that, squaring that means we have to multiply a minus 2 by itself. We still need to bring down the plus 3. Now we need to FOIL this out. A times a is a squared. You get minus 2a. In the middle, you get minus 2a. And then negative 2 times negative 2 is positive 4. And bring down a plus 3. And if we simplify this, we have some like terms. These are like terms. So are these. All right, so we can bring down the a squared. If we add our negative 2a and negative 2a, that's negative 4a. And 4 plus 3 is 7. That would be your final answer, a squared minus 4a plus 7. All right, let's look at part B, f of a minus f of 2. Kind of have to deal with this separately. We've got this f of a, right, and then we got this f of 2. So two different function notations. So first part, f of a, means in the x's spots, we're putting a's. So it's going to be a squared plus 3. Then, of course, the formula has a minus sign in it. And whenever you're subtracting, be careful. I would subtract this whole part in parentheses because you're subtracting all of it. And this part means we're plugging a 2 in for the x. So in this x's spot, 2 squared plus 3. All right, and we have to simplify that. You really can't do anything with a squared. So we have a squared plus 3 minus, all right, in these parentheses, we could do some simplifying. 2 squared is 4. 4 plus 3. You guys know 4 plus 3 is 7. So we have a squared plus 3 minus 4 plus 3 is 7. And then, of course, these are like terms. We can add them together. 3 minus 7 is a negative 4. So you get a squared minus 4 as your final answer. Equals 4 over x. Simplify f of 3 over x plus 2. So again, this is function notation, all right? This means we have to plug all of this in this x's spot. Think, kind of wipe that x out, all right, and plug it in. So I'm just going to rewrite the problem. The problem is f of 3 over x plus 2. And that means in the x's spot, that's what we're plugging in. So we'd have a 4 on top all over. In this x's spot right here, we'd be plugging in this 3 over x plus 2. All right, and then we have to simplify this. All right, we have basically a fraction within a fraction. The denominator is a fraction. All right, so you have to remember how you divide fractions. I think most of you probably learned instead of dividing fractions, you change it to multiplication and you multiply by the reciprocal of the denominator. So maybe we leave this 4. I might call this 4 over 1, right? 4 divided by 1 is 4, so 4 over 1. You could change it to multiplication instead, and you could flip your denominator. Your denominator would be x plus 2 over 3. Let's put that in parentheses. All right, and then you could carry out the multiplication. On top, we could distribute. You'd get 4x plus 8, and on the bottom, 1 times 3 is 3. That could be your answer. All right, I want to show you guys one other way to do this. I know this is probably what most of you learned, all right, to divide fractions, to multiply by the reciprocal. I think I have a shortcut, all right, that a lot of kids usually like. All right, my shortcut for dividing fractions what it is, I call it the outside inside trick. Right, I'm going to show you guys how to do it. You can decide if you like your old way or this way better, but I kind of think this way is a little bit easier. All right, so I'm just going to erase this, pretend like we didn't do this problem. All right, from here, if you were trying to, all right, originally there was a 4 there. All right, if you were trying to do this math, do dividing by a fraction, all right, I always make sure the numerator and the denominator are fractions. My denominator is a fraction, so I'd make my numerator a fraction, but then what I do is I take the very outsides, the very top and the very bottom, All right, I call those the outside, all right, and I multiply those together. Those become your numerator, 4 times x plus 2. All right, then I multiply the insides. The 1 and the 3 are on the insides. You do 1 times 3. And then you could do the math from there. Distribute, you get 4x plus 8. All over 1 times 3 is 3. And you get your final answer. I just think sometimes it's less writing the outside-inside trick, but it's up to you. You get the same way or the same answer either way. All right. Why don't you guys give the next one a try? You're just dividing these fractions. You could do it the old way, or you could do the outside-inside trick to get some practice to see if you like that. So I would press pause, do the problem yourself. When you're done, press play, and I'll explain it. All right, so I'm going to do the outside-inside trick here to divide these fractions. So the outside is the very top and the very bottom. You multiply those together, that becomes your numerator. All right, and then the insides, you take the insides and you multiply them together, 2 times x plus 1. And then it's just your job to simplify. Distribute on top, you get 5x plus 10. Distribute on the bottom, you get 2x plus 2. And that's your final answer. All right, again, that's the outside-inside trick. All right, you also could have done, call this method number 2, where you change it to multiplication. You would have had 5 over x plus 1, change it to multiplication, and you'd take your denominator and you'd flip it. All right, and you could do the same thing. Distribute, you get 5x plus 10. All over on the bottom, if you distribute, 2x plus 2. Oops, 2x plus 2. Again, you get the same answer, so it's really up to you how you want to do it. All right, but when I refer to that outside-inside trick, this is what I'm talking about. All right, hope you guys found these notes helpful. If you have questions, contact your teacher. Otherwise, you could get started on the day 1 homework.